All right, I told you in the next problem we were going to have to deal with some factoring, and here it comes. So notice that this and this are both the same, and so I want to replace 6x plus 6 with a factored form. And so I'm going to take the 6x plus 6 here and here, and I'm just going to be doing GCF factoring because this isn't a quadratic. Let's go ahead and find our GCF between 6x and 6, and that's going to be a 6. And then when I divide 6x by 6, I'm going to be left with an x. And then when I divide 6 by 6, I will get a 1. So this is the factored form, 6 times x plus 1 in parentheses here. Now we look at everything else that we have left. This x plus 9, that's already a factor. There's no GCF I can pull out or anything. But here in green, this x squared plus 6x minus 27, that's a quadratic. So I need to factor it using an x box. So I'm going to take this, and in green down here, I'm going to go ahead and factor it. So let's start. Remember that it is a times c. So there's an implied 1 here as my a value and negative 27 for c. So that will overall be 1 times negative 27, or negative 27. My b value, the one in the middle, is a 6, and that goes in the bottom. So I'm looking for factors of negative 27 that will add to be a positive 6. That means that my bigger number, which is the one I normally write on the right-hand side, will be positive. So I'll start with negative 1 and a positive 27. Negative, let's see, 2 won't go in, but 3 will, and it's 3 and, or negative 3 and 9. And if I do negative 3 and 9, that will add to be 6. So that's what solves my X puzzle. Now I want to do my box. I'm going to fill in x squared and negative 27, and then remember, take your factors and put x's on them. So 9x and 3x, and don't forget that this needs a negative sign on it. Negative 3 and a positive 9. All right, let's keep going. I want to find a greatest common factor between x squared and negative 3x, and that will be an x. Between 9x and negative 27 across the second row, that will be a 9. Down the first column, x squared and 9x have an x in common, and then negative 3x and negative 27 will have a negative 3 in common, remembering that the negative sign here means I need a negative sign here. All right, so I can rewrite my factored form of 9x plus 9 and x minus 3. I have now factored everything, and I want to rewrite my entire rational expression here and here in factored form. So let's start with the numerator of my first rational expression. So 6x plus 6 became 6 times x plus 1. And then I'm dividing that by x plus 9. Now I need to multiply by what I had in green, which my factored form was x plus 9 times x minus 3, and then finally divide that by another 6 times x plus 1. All right, so now that everything has been factored, I have 4 individual factors here, or really a greatest common factor and 3 factors. And here I have an x plus 9 multiplied by a 6 multiplied by an x plus 1. We can kind of think of this as one great big numerator and one great big denominator. And so anything, regardless of which one of these it's in, can be crossed out if I see the same thing top and bottom. So I see a 6 in the top and a 6 in the bottom. X plus 1 in the top, x plus 1 in the bottom. X plus 9 top, x plus 9 in the bottom. So I am only left with x minus 3. Everything else got crossed out. Now I need to talk about my restrictions. What can x not equal? Well, crossing out a 6, that doesn't matter because that's not a term that contains an x. However, I crossed out an x plus 1, which means that x cannot equal a negative 1, because if x was a negative 1, negative 1 plus 1 would be 0. And remember, that's a no-no. So negative 1. And then I have another one here because x plus 9 also can't equal 0. So if I put in negative 9 for x, this term would be 0, making my entire denominator 0. So x can also not equal negative 9.